So far, we know what cluster analysis is, what a cluster is, and the final goal of the technique. What we don't is why it is useful. We already knew that the USA is in North America and Germany is in Europe. No data science there, right? There are many applications of clustering. I will give you two different ones: market segmentation and image segmentation. Let's start with market segmentation. If you work in data science, that's where you'll most definitely apply your clustering skills. Imagine a retail chain that sells clothing. Its marketing campaigns have been disastrous in the past few years. You are appointed as the data scientist of the company. The firm gives you all the data they've gathered and give you the green light to create their next marketing campaign. You have no idea who buys the product, so you decide to create a scatter plot of all customers depending on the amount of money they spend and their age. The result is the following. Cluster analysis allows you to identify 4 big clusters: young people who spend a lot, young people who spend a little bit, middle-aged people who spend a lot, and ones that don't spend much. What you have done with this analysis is to identify the target customers. There aren't many older people who are clients. Moreover, most of the data points are middle-aged people who spend a lot. That's most probably who we should aim the marketing at. Okay. Clustering is often used as a preliminary step of all types of analysis. It is a very useful technique for exploring and identifying patterns in the data. Data scientists often turn to it when they have no idea where to start and what to expect. Cluster analysis is rarely the sole method used for drawing conclusions, but, as we already mentioned, is a great starting point. A more interesting and definitely more visual example is image segmentation. Let me show you a photo. Can you tell what this is? Or maybe who this is? How about now? That's called image segmentation. Here's the original image. It is a dog with glasses and a bandana. This photo is very cool for image segmentation precisely because there are some elements in different colors which can be segmented. Each color in the photo is a different cluster. In the first photo, we have 3 clusters: the white one, the kind of beige one, and the dark one. That's why it is so vague. The dog is blending with the ground. In the second one, we have 10 clusters, or 10 colors. There is already enough detail to see that it is actually a dog laying on the ground. Moreover, the color of the bandana formed a big enough cluster to actually preserve its blue color as a separate cluster. Can you guess how many clusters there are in the third photo? 30! Although it seems like a small improvement, there are 3 times more colors than in the second one. And we can already see details like an ear and different colors of the fur. Notice that in the RGB color model, there are 16,777,216 possible colors. So, to reproduce a whole image, we would need that many clusters. And by the way, that does not mean that the colors will be perfect. Some of them may blend, while others may be reversed. Now, we just turned a 17 million color photo into one with 3, 10, or 30 colors. Such simplicity implies smaller size. And in fact, we have compressed the photo. That's one of the uses of clustering. For a short period of time, we thought that clustering could be applied for object recognition in computer vision. While it looks all right, there are some problems with it. So clustering has made way for better techniques which have been developed to help machines detect the world around them. All right. In all our courses, we focus on the business implementation of techniques. That's what we will do once more, but be sure that you can easily hop on to other types of problems once you finish this section. Thanks for watching.